Hi, everyone. Welcome. My name is Ahmet. I'm a research scientist in Cohere for AI. I'm very happy to have Orhan with us in our Fire Chat series today. Orhan is a senior staff research scientist at Google DeepMind. He did his PhD in Middle East Technical University in Turkey, focusing on sequence modeling and applications on multilingual neural machine translation. After his PhD, he did research at Mila Montreal, IBM, METU, and he's at Google since 2017, if I'm correct. He has been working on different areas: sequence modeling, machine translation, multilingual models, multitask learning, and large language models. And he was co-authored many great works, such as massively multilingual neural machine translation, Extreme, Extreme R, Extreme S benchmarks, GPipe, and PAL. So feel free to drop any question throughout the webinar to Zoom QA. I will leave some time at the end, but also based on the flow, Orhan may directly answer your questions. So I would like to kick off now. Welcome again, Orhan.
Thanks a lot. Thanks for inviting me. Thanks for the generous introduction. It's really a privilege to be here. Thank you.
Yeah, probably I missed lots of things, but I will try to catch up throughout the webinar, throughout the chat. So I would like to start with this. I know we are from both from the same university. We studied in the same university in Turkey, but unfortunately we didn't met at the time. Long after we met very briefly. So I'm very curious when your journey really started. I mean, all before PhD and everything. Like, when did you really get kind of interested in maybe computers or maybe engineering? What can you tell us about that?
Sure. When did I got interested in computers and so on? So that's I think it was another toy when I was a teenager, and before that I was mostly in in Nintendos and other type gaming mediums. But I would say around like when I was 11, 12, that was the time that I first had my own PC. And I started experimenting myself back then quite a bit. Internet was quite new. Those dial-up modems and so on. That's what we were using to connect the internet and experience. It was really early days of, I think, internet, at least at the places that the place that I used to live. Yeah, that's how that's when I first met with the computers. But then how I got into doing grad studies, that was around 2009. My undergrad is actually on operations research, so that was my major. And it's a funny story. I was thinking of doing some, grad studies, and I applied a couple of areas. So I applied to operations research. A friend of mine told me, okay, why don't you also apply to computer science? You can do a grad study on computer science because you're interested in. So why don't you give it a try? And I said, yeah, okay, why not? I also applied to computer science to do grad studies, and actually my own my own field did not accept me to do a grad study, but computer science gave me a shot, but with a condition. They told me, okay, we're gonna allow you to do a grad study on computer science, but you have to take all the undergrad courses that are required to be a computer scientist, or computer engineering, sorry. So I actually spent 1.5 years taking all the undergrad courses as a grad student, starting from the first year undergrad to fourth year undergrad. I actually completed, I don't know, 15, 20 courses in 1.5 years. It was a very intense period of time. And then after I passed all those courses, they allowed me, okay, now you can do the computer science, the grad studies. That's how I started doing it. This is, by the way, circa 2009.
Yeah, so it's 15 to 20 courses are really a lot. So probably there are multiple courses that you really didn't like. What would you say about that?
I mean, not didn't like, but some of them were really hard. So because I was asked to take all these courses in a very compressed period of time, and there are some dependencies, prerequisites for some courses, and I was actually taking courses at the same time, which is actually prerequisite to each other. Like think about the C programming with programming languages and operating systems. I was actually taking all these three courses at the same time in the same semester. Some of them I was trying to actually study a little bit further to get more understanding for the other course, to help the other course. But it was a very intense period of time. Yes.
I see.
Yeah, that's how I started. And then I started my PhD, so like actually grad studies in a lab. And my lab was mostly a pattern recognition, machine learning, and there were a lot of applied stuff also happening. Some folks were working on the theory side of things. Some folks were working on the applied side of things. But it was a very diverse lab in terms of the areas and the topics that are being studied. There were really theoretical folks working on the theory side. There were people who were applying it on remote sensing, medical imaging, signal processing, vision, and so on and so on. It was a very large lab with a diverse set of applications and theory. Yeah, so I was lucky on that regard because it allowed me to see, okay, like there is theory on that side, but they also applied to these many different areas. It was quite a teaching experience.
I see. That's actually quite kind of similar because I also did my bachelor in electrical engineering, and in 1 year I only get the chance to have some computer science courses, so I can relate with that. So I also had some courses that I really like, but some courses that I really don't like, especially hardware level courses. So yeah, but I will come to point where when you kind of go through ML and NLP. But before that, so you mentioned like you had a different undergrad, then you move forward to computer science. Did you think like, okay, this is really what you wanted, or at the time you had maybe not that much? So what do you think?
I mean, like I didn't know much. I didn't know, and it was also an exploratory thing for me, and it was uh, like I took the risk, but I was at the position, and I was at the time to be able to take risks. Not that I'm not now, but back then, I was probably more open to new challenges, new frontiers, and so on. So that felt exciting back then.
Yeah, definitely that's quite exciting. Then you mentioned like you had chance to see different areas in ML in your lab, which is probably really nice, especially when you start your like a research career in general. And what was the motivation that forward you to more like a natural language processing or machine learning in this ML in NLP domain?
Okay. Full disclosure, I'm not proud saying that, but I've never taken an NLP course. So I'm more of a self-taught NLP person. And I wasn't actually thinking about doing NLP up until 2014. And even then, I was like, no. I'm approaching this problem from a machine learning point of view, or I'm coming from that background, and I'm gonna apply what I know in this area as a machine learning person. I don't know, like probably the labels don't matter that much. At the end, we are all contributing to the scientific endeavor. Like everyone is putting a brick, and I think the more diverse the background is, the better the exploration. I found that to be a better mix instead of like developing a tunnel vision on a topic. But NLP was not actually that's not where I'm coming from. I'm more coming from the sequence modeling side of things. What I mean by that, you're trying to build a predictive model that is predicting, the what's coming next in the sequence, or you're trying to put a statistical model on a sequence, whatever that sequence is. So like I worked on speech, I worked on I worked on medical imaging. These all come actually as sequences. Even if you look at hyperspectral imaging, remote sensing, they also actually have some signal processing aspect where you can actually rest or you can serialize everything into a sequence and then process it that way. So yeah, that's where how I entered the NLP realm, I would say.
I see. I think that's quite valuable because I mean, in some places like there's always this discussion like, okay, I love language, then I jump to machine learning and NLP with that motivation. But some people also say like you actually have a different background, but the where these two different approach meets is probably quite similar places, which is quite nice for our field, I guess. Right.
I can add
Uh,
maybe a bit more color that may you know, a lot of things happen out of luck. You know, I was just lucky to be at a place. Some things were happening, and you know, lab environment if it is lively and vivid, so you actually eavesdrop something, or you learn something, and you get like interested or excited about that thing, and then you start exploring. Or some things came out of necessity. In my case, it's a combination of the two. There were a lot of people actually working on different problems in my lab. And back then in 2010, 11, like either SVM, support vector machines, kernel machines, and graphical models, they were big. They were the hot topics. And depending on the problem, either you were using this toolkit, but independent of what you like the surface level tools, you also need to build a lot of features. Feature engineering was a big thing. And I worked on three different problems. One vision, like core vision, one medical imaging on basically doing fMRI brain decoding, and more theoretical stuff. In all these three, I spent so much time learning the domain specific stuff. For instance, I took courses to work on fMRI, doing brain decoding, machine learning on fMRI. I took several courses from psychology department, physics department. I actually learned how to operate an fMRI machine after I think a year or and a half. In this game, I was finding subjects and then driving them to the fMRI center, designing the experiments, collecting the data, cleaning the data, and then I was doing, you know, my actual work, machine learning part. And then I switched to remote sensing. Again, there are a lot of like hyperspectral images courses, HDR courses, this, that. And then I switched to another area. I said, no, I cannot keep taking all these courses. I need to find something that generalizes this whole domain specific feature engineering. That's where I met actually with representation learning with neural networks. So that was my segue. So I was interested in, okay, maybe I should learn. So that will save me a lot of time. That's the necessity part. I said, okay, if I learn how to automatically learn representations, and if it generalizes to different problems, then it'll save me a lot of time from getting a lot of other courses. So that's you know, the different application I was seeing, and I was jumping from one to the other. But there was also some necessity to find something common, at least in terms of the toolkit that I was using. So it's for me, it was a combination of two that was the segue for me into neural nets.
I see. I mean, it's probably for the students now doing their graduate or undergraduate. This is slightly bit like a different way, because back then this was the case. The neural network was not like the dominating paradigm, even like it was really new at the time. But now probably everyone just starts with the neural networks. So there are no this kind of sideways. Maybe there are different sideways, but I think this is some kind of luck for us, because there is more contextual understanding, at least like motivation wise, for the neural nets.
True. Yeah, agreed.
Yeah. Actually, I also, when I look at your resume in general, and I trace back your works, I see that you work with. I mean, let's start this way. Like you actually go to Mila, Montreal, maybe before even you finish your PhD, I guess, right?
Correct.
So in Turkey, like I know, I mean, people know, like this is really a thing, especially in the top universities. Lots of students want to go US, Canada, European universities for multiple different reasons. So what was your reasoning, or what really you wanted to do?
Okay, then I'll pick up from where I just left. This like how I met with representation learning, and then because there's that's the context. I started working on representation learning, but I was actually like a self-taught learner, and I was actually finding out of courses in the making on the web. This is around 2011, 12. And there were not that many materials around. And I found a couple of courses teaching like neural networks, representation learning, back then it was more like autoencoders, RBMs, and so on, or deep belief nets, that they were big back then. So I started learning these myself. I was also implementing, build a library for myself. I was doing all this as on my own time, because my lab was a little bit too much into I'd say classical methods back then. The most advanced thing was graphical models.
Mm-hmm.
Anyway, so I was working on these neural nets. Like I was building my own libraries, using them to solve problems and so on. But then I decided that like I should work on this, because that's what I was excited. I was able to solve actually many problems with a very simple library that I put together in MATLAB. I was able to solve pretty much everyone else's problem with the single library, doing only like the learning features from the data. And I was at the point that no one else knew neural nets in the not only in my lab but also in the school and also in the country. And I passed my qualification exam, PhD. Then I started looking for people who were actually doing this or specialized in this area. What I did was I literally sent cold emails to the labs and professors that I knew working on this. I sent, I don't know, 50 to 100 email to professors, labs, or like postdocs, PhD students that I was reading the papers, and Yoshua replied. So I said, okay, let's meet. There was a quick interview, and then he said, oh yeah, okay. So if you're interested in these areas, come here. And I went to Montreal. This was I think around 2013 and 14. Around that time, I visited his lab. It was a very small lab back then. I think 20, 30 people at Mila. It was I think called Lisa back then. Yeah, that's how I went to Mila as a visiting PhD student and started working with Yoshua. Then later with Kungyun Cho was a postdoc there, and we started working together. And that's also my segue into NLP. I was working a lot on the sequence modeling, there were that was the early days of like language modeling, using language models to build sequence models, and then use it to solve actual problems like machine translation. And that was an emerging area in the lab. The people were still working on attention, like Badanal's paper. Dima was there. Everyone was there. It was a great and lively environment that people were all interested in, coming from different backgrounds, and trying to solve a problem that no one has any experience on, which is machine translation or NLP. Yeah.
Yeah, that sounds really great. I mean, I would like to talk more on this part, because it's really nice bridge for the research. But just before, because you mentioned like you start to work with Bengio and Cho later on, and they are probably, even at the time they were kind of big names. Now they are really big names. So how was working with them? What did you learn from them?
Back like in 2013, 14, at least Yoshua had a lot of time to he was able to sit with you and then look at your experimental results, or even sometimes the code. He was one thing that still sticks, that I still remember. The thing I learned from Yoshua is like don't believe on things just because you really respect that person, or if just don't really believe everything a person says, even if that person is like a high profile person in the field. And he was actually referring to Jeff Hinton. There were, I think, distillation, or I don't recall exactly what the what was the context, but that was about a recent paper from Jeff. And then everyone in the lab were very excited jumping in, and then everyone was saying, oh, this is the future that should work, and so on. And I remember Yoshua saying, look, like, don't believe it's just because coming from Jeff Hinton. You got to experiment it, you got to blend in it with your intuition, and then you got to, at the end, look at the numbers, like look at the data and see it yourself before believing it. Yeah, that's one thing that really sticked. Yeah, because everyone is able to make mistakes, or everyone may oversee something. Yeah, that was one thing that I remember with my experience with Yoshua. And then of course he became super busy. Weekly meetings become bi-weekly, monthly, and let's meet when needed basis later. Yeah.
I see, but it's really nice start for also becoming independent with this intuition what you learn, and yeah, I think it's worked out well apparently from now. Yeah, actually, from now I would like to talk a little bit about your research because you had a really nice bridge from that. So when I see your papers, I mean, you work really a lot of things, but there is one thing that keep coming, and you still probably working time to time about machine translation. So I think machine translation, neural machine translation in particular, has really a special place in our field because, in my intuition, like it's a quite challenging task. At least it was really a challenging task, and it has multi-dimensional challenges. So maybe that's why like all these early sequence models, attention, then self-attention and transformer actually either proposed for or benchmarked on NMT, right? Is this the reason that you were also working on NMT, or do you have another like special interest on machine translation maybe?
I honestly don't have any special interest in machine translation, but it's a great test bed. It's a very well studied area since 50s, actually, like at least with the statistical methods. So it's a great it's a great benchmark to test your ideas. There are not that many moving parts. There are things that are quite under control, and evaluation is quite mature compared to the other areas in NLP or in other areas in machine learning, because it's a real world problem. So people can see the results, and then you can actually get evaluation results from the users as well. So that's why I think evaluation is quite mature compared to the other areas. So it allows you to rely on the signal that you're getting, the hill climbing signal that you're getting in any of your experiments that you're doing. So it's giving you a clean sheet if you have a hypothesis, or if you want to test a new machine learning algorithm, or if you have a new thing that you would like to apply it on a challenging problem. The other pieces, there were, at least back then when I started, there were tons of supervised data. And then supervised learning was the biggest thing. This was around ImageNet, which was again relying a lot on supervised learning. And if you have a lot of supervised learning, like if you have a lot of data that you can do supervised learning, so you can work on other things like, okay, like either architecture, optimization, or you can also control what happens if I decrease the amount of supervision on one task and increase it on the other. It's a good test bed for multitask learning if you're applying it on the multilingual learning, but also continual learning if you're learning tasks in sequence. Optimization is again a good area to study in the machine translation setup, because a lot of data. So yeah, these were I think it created the perfect environment for anyone to actually start with with applying the machine learning algorithms in a real world problem.
I see. I mean, I totally agree, but it's also interesting because you have really lots of work on direct on machine translation. I mean, as you just said, you have an algorithm and you want to test on the machine translation, but with a poor view of your papers, people may think, okay, there is a special interest on machine translation apparently, which would be also valid. I don't think there's any problem on that, but I totally agree because also really lots of big things came from like a labs that's work on this and test on machine translation. So which is really an interesting point. In terms of like you said machine translation also allowed to work on multitask problem, especially in the form of multilinguality. So I'm really interested in multilingual models, multilingual learning in NLP. So do you have also like maybe not big in the beginning, but later on, did you get a taste of maybe more like a research taste in terms of multilingual models because you have some of the early works on this one model for multiple languages in an NMT at least.
I'm not sure. Could you elaborate a little bit more about?
So like multilinguality now, do you think this is only about like a test bed for multitask learning problem, or do you have another intuition in terms of opportunities or maybe different challenges for multilingual learning?
It's a great, it's a good challenge for multitask learning, but also if you want to stress test generalization, it's a great test bed again. And it's a real world problem. Whatever you do there, you can actually use. So it's not like super theoretical or like super basic research that has a long that has a long trajectory towards making impact in production or like in real life. It's very close to actual problem. So for me, it was mostly about generalization. So we were doing in like 2014-15. It was no one was sure about whether this neural approaches for translation is going to work or not. But around that time, we showed, yeah, it works. But then the second question was, does it generalize to other things? And that's when we branched. Calvin Shu, Yao Li, Jamie Kiros, Jimmy Bott, they took the route from, they branched out into, can we apply this problem into, can we apply this solution to multimodal approaches, like image captioning, even image generation using this framework. And me and a few others, we branched out into, can we apply this to like more multitask learning problems in the realm of multilingual translation? And the goal was there, at some point, we can actually merge these two branches together. And I think almost 10 years fast forward, yes, now we can. Back then we were expecting this to happen a lot sooner. But then when I branched out into the multilingual translation, the problem was really a multitask learning problem. And that was my motivation, because some tasks are difficult, some tasks are easy. You're seeing actually transfer from one task to the other, or you're seeing interference of these tasks, and these are all related or all interacting with also the amount of data, the quality of the data, the particular architecture, or the way that you optimize the models. And if you can think about the can I scale a model from learning the association between 2 languages to 1,000 languages? And that was actually the route that I've taken for almost 5-6 years. The goal was reach to 1,000 languages, because the hypothesis was, if you can build a system that can generalize across these 1,000 languages, then you can. That's a proof by demonstration, basically. So it was an empirical path, but showing, okay, these models truly generalize to new languages, or a single model can extend to all 1,000 languages. Yeah, I think it was a good confluence of these two things.
Mm-hmm. I see. Yeah, that's totally. I mean, I totally agree. Like, because there are maybe different challenges that you cannot find in other similar problems, because I mean, different languages has really intriguing properties in terms of transfer. But like a follow-up question in there, how do you define the progress? Do you think we are there or still we are not there yet?
We're there in terms of the way that we defined it 5 years ago, but I think we need to redefine it. Now, in the past, we were just defining the goal as being able to translate from 1,000 languages to 1,000 languages in the domain of X, up to the sequence length of, for example, at sentence level. Now the task, I think that problem is pretty much solved. At least we know the solution. If you tell me, okay, I have this much data on this language, uh, like what is the best recipe? I can actually tell you a recipe. There is not too much research. Of course, there are problems that require research, but at least we know the broad strokes of the solution or the solution space. We have a good partitioning and understanding of the solution space. In terms of extending this to new applications, because now our models are capable of doing a lot more things. Okay, I was able to do machine translation, but can I combine it with more creative ways of cross-lingual generation or understanding? So this problem needs to be redefined. I think the field is going through that transition right now. If you think about the latest generation of large language models, they're doing good, like they're doing pretty good in translation, the task of translation defined by, for example, WMT. The task is almost like, I was checking the results on WMT 23, and like GPT-4 or models from Google, actually, they're quite competent compared to specialized system doing this. So there's a generalist model performing really well on a well-defined problem, and actually beating the specialized models for that in that domain. So now, but it's more of an opportunistic take, but I think we can use this generalist capabilities that we were not using or we were not measuring for this problem of machine translation. What else this new model that has new capabilities is allowing me to do beyond the task of the translation, like, or task of sentence to sentence machine translation. And that goes into translocalization, transcreation, or say cross-lingual control generation, right? So the task of translation needs to be defined as perhaps the application could be, I'm going to write a letter to my landlord in Japan to extend my stay, right? So, and this is my blurb that I used for that I sent to my landlord that I sent it in the US. So there, this is not really a document-to-document translation tasks. You need to also combine with the world knowledge, what information that culturally is more appropriate, or how you approach the seniority, or there are a lot of things that these large language models capture that we can use to redefine the task of translation. So I think there's a lot of now demand from the people who are doing benchmarking evaluation to refine these tasks now, because the models that we have are quite capable. Yeah, and analogy that I commonly use for this. So we have street lights, traffic lights to control the traffic of cars, right? But now we have built spaceships. And if we insist on using traffic lights to control the orchestration of these spaceships, so we're not going to be getting enough signal. It's not enough. So we need to redefine Houston, or we need to redefine air traffic control to be able to navigate ourselves. And this is pretty much a benchmarking and evaluation, or redefining the task problem, I feel.
Yeah, that's a very nice analogy, by the way. And I was just going to say, like, really, you define the machine translation is super nice test bed, but when you, especially with the current capabilities of LLMs, when you go beyond that test bed, then things are not that concrete anymore, right? Even like evaluating multilingual an LLM. So we have a project, and now evaluation is one of the biggest challenge, because when you look at translation, okay, it works pretty well, even if you scale with a small model size. But then if you look at the creative generation, I don't know, cross-lingual generation, then things are not really well defined even to understand this model is working well or not. I totally agree with that. Yeah, I think we come to point that we have to talk a little bit about at least LLMs, because I mean we are living in a world of LLMs in a way. There is a huge interest, and there is also like a super fast pace, I would say. So my question is not really about like the technical details, but maybe a bit more like a focus out. And were you expecting such like a hype? Maybe hype is not a correct term, but like were you expecting such high pace or progress 5 years ago or so? Or how do you see the current LLM space in general?
I wasn't expecting this much of an interest because I'm not well informed, or I'm not, like, I don't have enough information to form an educated opinion on when research becomes part of daily life of people, and that's where the excitement is coming. But as a researcher, if I look back at 2015, 16, yeah, this was coming. We were always trying to build the largest language model. Like, we have a paper actually in 2014. Okay, let's build the largest language model and then plug this into a sequence-to-sequence model to drive the generation. And we knew that it was going to give us boost in terms of quality, like stacking more layers. So it was apparent. But the theory of this came with a few papers, I think, starting 2016 on iClear. I think the best paper award was given, looking into the generalization memorization of neural nets. And that was the first empirical, not empirical, but theory, trying to come up with a theory showing, look, this is almost a sure shot. If you scale, it's gonna get better. So in 2016 and on, it was all, yeah, let's scale and then see if it breaks. As a researcher, I was approaching this. Yeah, I had never seen the scale, like the benefits of scale saturating. So it was always, we've been trying to scale things more and more. But of course, I wasn't expecting this much of a hype. But I think that hype is also knowing how to integrate this new technology into daily lives of people, the way that people can interact easily, like with a chat API, right? And those models were out there. So we also had similar models at Google that I was interacting in a different way. But the interface that's not my area of expertise, but that ease of use, meeting with the people and knowing how to meet with the people, I think that created a lot of excitement and interest that I wasn't expecting.
Yeah, I mean, I have like really interesting thing about that. Like, I think 1 year ago or so, I went back to home, Turkey, and my sister definitely doesn't do anything about ML. She indeed actually do operational research. I mean, works in something in that line, but she was actively, very aggressively using DALL-E to generate images. Like I was thinking, I am a machine learning researcher and I am not using at all. So then I understood, okay, this is something else. Of course, after the chat GPT happened, and yeah, definitely now we are in a different phase, I guess, in terms of like public opinion. Maybe in terms of the research, we knew that was going to come. It was coming, but yeah, I think that's really something interesting as well. So I would like to. We are moving from you to your research. Then now I would like to move to you again a little bit. So I see you work on multiple things, different topics, different projects. So, and there are lots of projects probably at Google you are involved in. But how do you what is your daily routine? How do you work day to day?
Day-to-day work at Google. Okay, this. So I'm responsible of some areas at work that are either defined by my interest or a joint interest with other groups. And like my day-to-day work, mostly looking at experimental results, kicking off new experiments, having some brainstorming sessions with folks to form new experiments or try to identify or debug something. And once in every while, I also do some planning. Well, okay, like what is the to not forget about the ultimate goal, at least for the next 3 months. What are the objectives, and how we can split into milestones, and then research questions. From those research questions, some research projects, and then each research project has multiple work streams, and forming those work streams and making sure every experiment is actually headed into or aligned with the ultimate goal of that, say, milestone, and then accordingly with the objective of the project that I'm working on. I mean, I gave you a very abstract or high-level day-to-day routine, but that's pretty much what I do. I look at experimental results, kick off new experiments, and then making sure whatever the hypothesis that we're forming is aligning with the objective, and also experimental results that we're getting are reliable and informative, so that we can build on top of them.
I see. Actually, here I just noticed that there are some really nice questions. So I will leave some of them to the end. But there is one just on the spot. Virat asking, how do you iterate when working on research with longer feedback signals? Because you said your daily routine also includes like checking experimental results, aligning them with the ultimate goal. But how do you iterate in this context?
I keep a portfolio of projects that are all kind of overlapping, but spanning different horizons. So one project, for example, targeting something long-term, and another one accompanying that, targeting more midterm stuff, and then another project like more short-term, attacking low-hanging stuff. So keeping a portfolio, it allows me to, switch from one thing to the other, but need to be careful about how you define the portfolio. If these are very disorganized and it's all going into different directions, then you'll be just spreading too thin. But if you're careful about the way that you construct the portfolio, then they all become a multiplier for each other. The long-term project, it becomes a North Star for all the smaller or like short-term projects, and short-term projects become the driver or momentum builder for the longer one. That's what I try to do. Okay, if I lose my focus or if you exhaust the questions or exhaust the search space in this like short-term projects, then I look at the long-term project. Okay, what was the North Star? What are we trying to do? And then looking back at doing some retrospective, session to see, okay, these are all the results. Maybe sometime I found we diverge too much from the goal, and we need to rescope or respawn a couple of short-term projects that are aligned with the goal. So in short, like have a portfolio that is heading into one direction and taking more and more risks on shorter term projects, and keeping you busy and also informed. That again, maybe I'm also giving another high level or abstract answer, but if there's a follow-up question, happy to answer.
No, that's definitely makes sense to me, because especially in our field, you can have a project with, I don't know, 2-3 months, but also you may have an agenda to make it something more aligned with some ultimate goal. So having a balance and keep track on what you are doing is super, I think super nice kind of suggestion as well. So we have lots of questions. I want to comment them, but I have this kind of fun part that I will ask some questions really brief, and I would like to have a really brief answer, like maybe name of the paper or something in that line.
Like one word answer.
Okay,
all right, let's play.
Okay, cool. So who inspired you to start researching? that the path that you are continuing now?
Father.
Cool. That's a lovely answer, I think. Okay, second one. What do you think the most influential paper that you read and also forward you to this path as well?
2006 Hinton paper on deep belief nets.
Yeah, that's a very good one, I think. And what is the most influential paper of you that we should just read right away, right after this chat?
Trick question. Not the most influential or important, but a retrospective paper. I would recommend people reading 2015 or 16 multi-way multilingual machine translation with shared attention mechanism, with the lenses of back then we were very skeptic about sharing weights, and it was a very courageous attempt for us to share a module across different tasks with that mindset. And you'll find so many similarities, the way that we train the models. It's touching into infrastructure challenges, it's touching into multitask learning challenges in between lines, but it will at least, I think, help you ground. Nothing has happened in the last 2-3 years. It's actually, and yeah, like I was also building everything on top of other people have built over the like past 20 years or something. It might give some perspective and grounding.
Very nice suggestion. Actually, I looked at the paper before our talk because I wanted to get a sense of your path. So it is definitely, I think also I would say that's one of the starting point of your current path, I guess. Yeah.
Correct. Yes.
This is my opinion. Okay, last question. METU campus, which is in our university campus, or Google campus?
METU, definitely.
That was the trick question, and I think you got it correct. It's very nice. So now I try to collect, I will ask a couple of questions, and everyone please forgive me if I cannot ask all of them because we have like a 10 minutes or so, but I will do my best. So let's start with one of Vira's questions. So he asked, how did you develop a taste for different research problems to work on? Feels like there is a lot of focus on around LLMs. Curious how to be mindful about choosing what to work on.
Okay. I try to identify where things break. If they don't break, I try to break it. So scaling models to 1,000 languages was an attempt for me to break things and then see, okay, this is where it breaks, and I'll learn something at the point of things breaking. It's also the very way that babies or childs learn things, by breaking things. That's one way of doing. Pick up an existing thing and then stress test it and then see where it breaks. This may go into adversarial testing. This may go into scaling it up, or this may go into finding a new prompt that the models actually fail. And that's a good avenue. So if you can find what is unknown or where things are breaking, that's a great opening to new directions. And sometimes looking at some evaluation results are also quite telling. You may not need to also run the experiment yourself. Just staring at tables in papers, it may pay off.
I see. Yeah, that's I mean definitely breaking something. I think all the computer engineers, computer scientists have this kind of habit. Okay, let's break this. Maybe even just to reconstruct it, but also for research, definitely that I believe that works. Very good suggestion. So Alperen also asked. So I am mixing questions, by the way. How do you handle setbacks in research and in life? However you want to answer.
Am I? So it has the assumption that I am able to, but it's they're up and downs. So whenever I'm lost, I read papers. That's what I do. Focus on the things that are certain, and filter out the noise. And there are tons of exciting stuff happening there were many times either my hypothesis failed or I noticed I've been either scooped or someone else actually solved the problem for me. This happened during my PhD a couple of times. And I mean, yeah, don't give up without a fight in general. That's my motto. And there are always things that are there are always things happening that I find exciting. It's more, you know, in the moments of doubt, explore more. Yeah.
Yeah. Also, like I would like to add from myself, but to as a question. So setbacks are part of the play, right? But especially these days, if you imagine yourself as a PhD student, the pace is so much higher than probably when you were doing your PhD. Also, same for me as well. Like also mentally very challenging. What would you say about that? What would you suggest to like early career research grad students or new researchers for that?
Really filter out the noise and then don't look at immediate past. Look at like farther back. Read more uh, um, landmark papers that people still cite. Those indicate some problems that we have still not solved yet. That would be one advice. The other thing is if um, some areas or some problems are very hot, like building large language models, but and that's if you work on building large language model, if you work on pre-training of it, so do you have a big competitors in the game, right? uh, if you want to play that game, so that I mean you can play, there are ways to play that game, but there are also other things that these big players are not doing. Like I think it's going to be my third time mentioning it, but benchmarking, like no one is actually doing a good job in in benchmarking. It's the new frontier, and even industry is relying on academia to define the new task, define the task for me, find so that because that's more the expertise of academia, thanks to the academical background. Uh, and then if that is found, then that's going to be converted into a hill climbing signal by the big players or the players who are actually building these things, and then they'll hill climb on that signal. But the definition of that signal is an area that no one has great expertise, or it's not really scalable. I can throw thousands of chips on evaluation problem or defining new signal, but it's not a problem that I can solve by just throwing compute. Like finding the areas that are not able to be solved by the existing solutions or existing hammers. I think that might save you some time, also give you some inner peace, I would say.
Yeah. Also, it's like there, it's really nice direct suggestion as well. Okay, looking at benchmarks really is one of the most important venue now for also like in terms of like doability in academic people more comfortably can do instead of like pre-training like super large language models, which is really nice. Another question: how do you arrive at the conclusion to stop a line of work, especially when working on empirical areas where there always seems more to try?
How do I stop? If there's the return of investment, you see the gain either saturating, or for me it's like I'm not going to learn anything by running this or by doing this. That's my decision. That's my decision function. If I'm not going to learn anything out of this, yeah, that's the point that I say, okay, that's time. This is solved. Let's move on to the next thing.
I see. Cool. And another question, what good habits do you have? And I would like to add this, like maybe some practical things, maybe some tool you use or something to manage your time. Can you have any suggestion?
Um, Two things. My calendar is my boss. Whatever I do, it's in my calendar. So, and I say no. So that's the decision function again. If I'm requested to be doing something, I just look at my calendar. It's my boss. If there is no space in my calendar, then it's a no. So it's an easy way of saying no. That's one. My calendar is my boss. And the second thing is my inbox is my to-do list. So I tried so many ways of doing, time boxing things or having to-do lists, doing this and that. At the end, like I'm using this zero inbox, and if anything is in my inbox is in my to-do list, and I organized my inbox in a way everything goes in different buckets, so that I can keep track of things. It's a bit like time management, but those are the two I can that works for me.
Mm-hmm. And like these are also like allowing you to do the multitasking in a way.
There's no multitasking, I tell you. We're not creatures who can multitask. Yeah, at least not me.
I see. Because I feel like a context switching in a way. It is very common in what we are doing. Like maybe one, I was going to ask, but like since there are lots of questions, I see in your LinkedIn, I think you say you still do coding, and maybe you are coding for, I don't know, half an hour or maybe 1 hour, then you are returning back to a paper, writing a paper, maybe looking experimental result later on. So this is also hard to manage, I guess, right?
Yeah, my coding, by the way, I'm not coding like production level code. I'm just coding right now to keep my intuition fresh. So I'm just doing like opening up a collab, writing this, and then seeing, okay, this is how it works, and then forgetting about the collab once I build the intuition. I mean, that's that. I used to write a lot more, but that's not the case anymore.
I see. Cool. I think we've completed our times, but it was really lovely chat. I enjoyed a lot. I hope everyone enjoyed. So thank you, Orhan, again, and I'd like to thank also everyone joining. Yeah. If you have any last remark, go ahead.
Thanks again for inviting me and having me. Thanks a lot. It was delightful.
Yeah. See you, everyone. Bye bye. See you.